Hey everyone, hi, this is Rahul. I'm a graduate MITian and a postgraduate from Jadavpur University, Kolkata. I'm also a faculty in the field of mathematics and quantitative aptitude. So welcome to my YouTube channel. If you are here for the first time, I will request you to take a little time of yours and click the subscribe button so that you can get all the upcoming videos that I will be posting in my channel. We provide mathematics content starting from schools to the different degrees, BTech, BSc, MSc, MTech and lots. So today's topic that we are going to discuss is determinants from the chapter of linear algebra. So let us watch the video and get to know more about it.
So hey dear students, how are you doing? Welcome back to your channel, and today we are going to study determinants, which is lecture 7 of linear algebra series. So let us quickly get down to the contents that we will study today. So we will be dividing this particular lecture into two videos. In today's video, we are going to do minors and cofactors, properties of determinants, solving a determinant for a 3x3 matrix. So this is what we are going to talk about today. In the next video, this will be a continuation where we are going to talk about adjoint of a square matrix and inverse of a square matrix. So these are the two videos which will be compiled for one topic, that is determinants. Now let us start with minors of a matrix. So as the definition says, leaving the row and the column of any element, rest of the elements are its minors. Now let us talk about this particular matrix. As you can see here, in this particular matrix, so I found out the minor for the first one, M11. Here 11 is the address of the particular element whose minor I have found out. So here the first one stands for the row, the position of the row. So it means it is in the first row. And the second one stands for the position in the column. That means it is in the first column. So first row, first column, obviously I'm talking about this one. So here also you can see this particular address. So now how to find out the minor of the particular matrix? So for that, we need to first of all eliminate the row and the column which is the address of this particular element. So the row which is the address of this element, which is this row, and the column which is the address of this element, this is this column. So after eliminating that, whatever is left, the determinant of that will be the minor. So this four things are left, these four elements are left, as you can see here, A22, A23, A32, A33. So this determinant is the minor of the matrix of the particular element A11, and similarly for every other element you will be able to find out the minor. Now let us go to cofactor. So cofactor is just similar to that of finding a minor, only a little bit of add-on is there. What is the add-on? You need to multiply the minor with -1, whose power will be the addition of the row and column of the concerned element whose cofactor I am taking. For example, let us say the cofactor of A11. So 11 means I am talking about this one. So first of all, we need to find out the minor of this particular one. So when we find out the minor, it is A22, 23, 32, 33. I have already demonstrated that. Now with that, I am multiplying -1, whose power will be the sum of the row and the column of this particular address. So row is 1, this is 1, column is also 1, this is 1. So I am summing up the row and the column, and that will be multiplied with the minor. So that will give me the cofactor of the matrix. Now in order to figure out the determinant, the cofactor plays a vital role, because we are going to find out the cofactor, otherwise we won't be able to find out the determinant. So now before we start on with the determinants, let us talk about some of the properties of the determinants. The first one is determinant for a matrix A and a matrix AT is same. So what do you mean by AT? AT stands for the transpose of A. Now what is transpose of A? For example, if we talk about this particular matrix, now the transpose of this matrix will be simply when the row will be shifted in the column and the column will be shifted in the row, and that will be for every single element. For example, the transpose of this one will be, in the first row we will have A11, A21, A31. Now this will be in the row. In the second row we will have A12, A22, A32. This will be the second row. And the third row we will have A13, A23, A33. So this is about the what is called the transpose of this particular matrix. So this is point number 1. Now in both the cases, for matrix A as well as the transpose of this matrix, the determinant will have the same value. Now let us go to the second one. If any row or column of any matrix A is completely 0, then the determinant is also 0. Now this is clearly understood. Let's say we are taking any of the rows to be completely 0. We can take this row or this row or this row. Let's say all of the elements, all the 3 elements are 0. Then the determinant will also be 0. Similar cases for column. In any of the columns, if all 3 elements of the column are 0, the determinant will also be 0. Third point, if any 2 row or 2 column of a determinant are interchanged, then the value of the determinant is multiplied by -1. Let's say we are now interchanging the first row with the second and the second row with the first. So the first row now becomes A21, A22, A23, and the second row now becomes A11, A12, A13. Now if you compare the determinant of the previous matrix with the newly formed matrix, you will find that the newly formed matrix multiplied by -1 will give you the determinant of the previous matrix. So this is the point which has been told here. The next point, if all the elements of a row or column is multiplied by k, the determinant is also multiplied by k. Let us say I'm multiplying k with this particular row. So it becomes KA11, KA12, KA13. In that case, the matrix whose determinant, let's say, was x, now will be kx, because the k multiplied with a particular row is also multiplied with the determinant. Now let's say k is multiplied with the second row as well, it will be k square. If k is multiplied with the third row as well, it will be k cube. And like this, we will be finding out the determinant. The last point, now this is not exactly any property, this is just a definition. It says if the determinant of any matrix is 0, then the matrix is a singular matrix. This is just a definition which we need to remember. If you find out that the determinant of the particular matrix is 0, then this matrix will be defined as a singular matrix. Now let us go to the application. Now we are here finding out the determinant of a 3 cross 3 matrix. Let us take this particular matrix. 2, 3, 1, 1, 2, 3, 1, 1, 0. These are the 9 elements of this particular matrix. Now in order to find the determinant, as I have mentioned, cofactor is the most important tool, and we had represented cofactor by capital A with the address of the element. So now what we are going to do, in order to find out the determinant, we need to target any one of the rows. You can target any one. You can target the first one, you can target the second one, you can target the third one. Now here in this particular question, I have targeted the first one, so I will demonstrate it with respect to the first one, but then again I am telling you, you can target any of the rows, that is your choice. The answers will be followed up after that depending on which one you are targeting, but anyways it is your choice which row you want to target. So if you target the first row, the first one will be 2, which is the element, which is the first element, multiplied by A11, which is the cofactor of 2, plus the second element 3 multiplied by A12, which is the cofactor of 3, plus 1, the third element, multiplied by the cofactor of 1. So this is the formula. If you are targeting the second row, it will be 1 multiplied by the cofactor of 1, 2 plus 2 multiplied by the cofactor of 2, plus 3 multiplied by the cofactor of 3. Similarly, if you are targeting the third element, it will be 1 multiplied by the cofactor of 1, 1 multiplied by the cofactor of 1, and 0 multiplied by the cofactor of 0. So this is how we are finding out the determinant. In all the 3 cases, you will get the same answer. So let us proceed. So A11, that is the cofactor of the first element. So first of all, we need to find the minor, and for that we need to eliminate this one and this one. So what is left? 2, 3, 1, 0. As you can see here, this is the determinant, and we are multiplying it with -1 to the power of the address. That is, here its address is 1, 1, so it will be 1 plus 1, which is 2. Similarly, for the second one, 3 multiplied by, first of all, the minor, so this one and this one gets eliminated, so 1, 3, 1, 0. And we are multiplying it with -1 to the power of its address, which is 1, 2, so it will be 1 plus 2, which is 3. Similarly, the last one, the cofactor, first of all, we will take the minor, so this one and this one gets eliminated, so 1, 2, 1, 1. and we are multiplying it with minus 1 to the power of its address, which is 1 and 3. So 1 plus 3 is 4. So like this, now we are finding out the determinant. Now in order to find out the determinant of 2 cross 2, we need just to multiply this one. It is just a cross multiplication followed by a subtraction and again a cross multiplication. We will start off with this one. So 2 into 0 minus 1 into 3, which is minus 3. Again for the second one, 1 into 0 minus 1 into 3, which is again minus 3. And the third one, 1 into 1 minus 1 into 2, which is minus 1. So when we are putting all of these, now you will wonder why here we have put plus, because of this one. Minus 1 to the power of 3 is minus 1. Here also there is a minus, so both of them nullifies to become positive. Okay, so now you are just going to put the values and get the result, which is 2. So in this way, we can figure out the determinant of a 3 cross 3 matrix. So I hope you have understood the application of how we are finding out the determinant. Very important one. Okay, so if you know this one, now in the next video we are going to talk about the adjoint and inverse of a matrix, because determinant has a role to play in here. That is why we have demonstrated determinant before, especially in case of inverse of a matrix, determinant has a role to play. So we are going to discuss adjoint and inverse on the next video. Until then, it's bye-bye.